Okay, let's talk about question 828. To find what's the question, let's go through the example. The question is saying that we are going to give you a string, find all of the substrings, and then for all substrings, for each of them, count how many characters are unique, add them up, and return it. For example, let's say you have a ABAC. Here are all possible substrings: A, AB, ABA, ABAC, B, BA, and yeah, to the end. So now it's saying, okay, A, here we have one, here we have two characters without repeating, here we have just one character without repeating, here we have two characters without repeating. So 1 plus 2 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 1. That's the question. What's the question is asking us to do? Mm, okay, the naive or brute first or naive way to do that is to find all the substrings, find the characters that they are not repeated, add them up, and add them for all the substrings and get to the value that we are looking for. But we know that's gonna be a lot of, I think its time complexity is not good because we should create all the substrings. What's the easier way to do? If you remember from 907 issue example, let me go through that. Here we had something similar. We had an array. We wanted, the question was saying, okay, find all the subarrays. From the subarrays, find the minimum, add them up. So here we find out the same thing. If we want to find all the subarray and then find their minimum as brute forces, then it's gonna take lots of time. What was the better idea? The idea was, okay, let's say here one, we are gonna say one is the minimum for how many subarrays, and then we are gonna find out, and then we are gonna do the add up. So we are gonna see 2 is the minimum for how many subarray, and we are gonna do that here. I have another video for that one. We can borrow this concept. It's not exactly be the same because here we were using monotonic stack. Here we don't need to do that. Here we are gonna say, okay, here this A is uh, what's its share from the total value. So we know A, B, and that's it. So the share for this A is just 2, these ones. Because here we don't count it. We don't count it here. What is the share of B? 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5, 6. So the share of B is 6. How we can calculate what's the share? How do we know that? Again, we are gonna get it from here. The same idea. So the share of B is 2 plus 3, 2 times 3, which is gonna be 6. What is the share of 1? It's on the left hand side, it's just nothing. So 1, including itself, it's gonna be 1. On the right hand side, including itself, it's gonna be 2. So times 1 times 2. So its share is right, basically right hand side, right boundary times left boundary. That's inclusive. So include the A itself, including, okay. Now how we are gonna implement that? We are gonna go there are, that's the way that I came up with. I'm not saying it's the best way, but I think the time complexity is good. So we are gonna get a loop. We are gonna go through all of the characters in the string. If we find them, we are gonna put them in a dictionary. So for example, when here for dic A is it would be, okay, what is the number? It's gonna be, if let's say ABC, AB, what was our string? AB, AC was, okay. Dic A is gonna be equal to 1 and, or sorry, 0 and 2, what is going to be dic of B is equal to just 1. So here, when we make these ones, we know, then we can say, okay, for each of them, what's the left boundary and the right boundary. For example, here we know we have 2a, one is at index 0, one is at index 2. Here we know we have one in the index of b is 1. So what we can say? We can say that on the left hand side there is nothing, so it can go all the way back to the 0. On the right hand side it can go all to the end of the string. So this is, okay, we are gonna say, well, let's say if there is nothing, go all the way. So if it's the first item, so even here for 0, for this a, how much we can go to the left? All the way back to the first element. And how we calculate it? We are going to say here we are going to have another loop that's going to go through the values of these ones. We don't need the keys anymore. We're just going to go with these ones. We are going to get the array from that. So one is this one, the other array is this one, and we are going to loop through the arrays. So we are going to loop through this array. For the first one, we are going to say if its index is 0, or here in the index is 0, or if it's the first element, then the left hand side is start from 0. Okay, then also if it's not the first element, let's say here we know that this is not the first element, then its first element, or yeah, if it's not 0, then its first element is gonna be this guy, so it's gonna be 0. So array of I minus 1, which is gonna be this one plus 1. So here it can go all the way to index 1. We don't want to include a itself again. It can go all the way to the b. Okay, this we are gonna do the same thing for the right. We are gonna say if it's the last element of the array, then what should be? It should be the length of the array minus 1, because we don't want to index out. So here in this case, for example, for b, right is going to be 1 again. But for other ones, let's say for this one, what is going to be the right hand side? It's going to be this value 2 minus 1, which is 1. So for example, if we are considering what's the right hand side for this one, we know it can go up not to the a but to the b, so minus 1. Maybe this is something I had to do some trial to get the values, but then you are gonna see it's gonna work. And then what is gonna be our number for, okay, after you get that, you are gonna get, because we wanna be inclusive, we are gonna add 1 here. So index plus 1 minus left, right plus, or yeah, let's say right plus 1 minus index is gonna be on the right hand side. So for example, for b, we know it should be 2 times 3. So 2 times 3 is gonna be 6. For the first a, it's 1 times 2. For this a, we know it's 2 times 2. For c, we know it's gonna be 1, 2, 3, 4. 4 times 1. And then we are gonna add them up. If I resolve it, yeah, here's the thing. It's gonna give me different times, but sometimes it's good, sometimes a little bit. Okay, yeah. So it's good enough.